Hello friends, myself Dr. Mohammad Faisal Jaleel. I hope you all are doing well. I am here with my brand new video on Repulsion Motors. We all know the principle of repulsion, that is, when like charges or poles are brought close to each other, then there exists a repulsive force, or when unlike charges or poles are brought close to each other, then there exists an attractive force between them. You can see from here that when the like charges are brought close to each other, then there exists a repulsive force, and when the poles or charges of opposite natures are brought close to each other, then there exists a attractive force. We'll be now analyzing that how this principle is utilized in the repulsion motors. Now let us have a look on construction of repulsion motors. Like other motors, this motor also have two basic parts, stator and rotor. The stator of this motor carries a single exciting winding similar to the main winding of a single phase induction motor. It would be having a single winding, single stator winding, and this winding is excited with the help of a single phase AC supply. The rotor carries an ordinary distributed DC winding, and this DC winding can either be a lap winding or wave winding, which is connected to the commutator at one end, and the brushes are short circuited on themselves, and the single phase supply is not electrically connected to the rotor. So you can see that the rotor are not connected to the supply, and brushes are short circuited by themselves, and the armature of this machine is not connected to the any AC supply. Before going to the depth of this repulsion motor, let's compare this repulsion motor with the universal motor. In universal motor, as we know that the single phase supply is exciting the field winding or stator winding, and it is also exciting the armature and or armature or rotor winding, and this armature winding and field winding are connected in series, and these two windings are excited with the help of single phase supply or DC supply for universal motor. Whereas in this repulsion motor, we can see that the single phase supply or single phase source is exciting only the stator winding. The rotor is not electrically connected with the AC supply. The difference between universal motor and repulsion motor is that in universal motor, armature receives power by conduction, whereas in the repulsion motor, armature receives power from stator by transformer action. That is, the stator and rotor winding of a repulsion motor acts as a primary and secondary windings of a transformer. The rotor induced EMF is in such a direction that if rotor current were allowed to flow, the rotor induced EMF or rotor MMF will opposes the stator MMF. This is the similar case that we have seen for the transformer. We know that the secondary flux is always opposes the primary flux. The rotor MMF is set up along the brush axis. It is an important point to consider that the rotor MMF is set up along the brush axis, and we have to determine the position of brushes for torque production. So now we will be looking for various position for the placement of brushes. Let us have the first case when alpha is equal to 90. That is the magnetic axis of stator and rotor are in quadrature. You can see that the magnetic axis of stator and rotor is in quadrature, that is they are at 90 degree as shown in figure 2a. Therefore, there is no mutual induction between stator and rotor windings. Consequently, the voltage across the brushes is zero. So when the voltage across brushes are zero, the rotor induced current are zero, and hence there is no electromagnetic torque developed. So we can conclude that for angle alpha equal to 90 must not be the position for the torque production. Therefore, when will run when angle alpha is equal to 90, therefore motor will not run when alpha is equal to 90, since the stator mmf is unaffected by the zero rotor mmf. We know that the torque is produced when there is a interaction between the two fields or two mmf, and we know that there is no mmf produced in the rotor circuit. So for this condition, it is similar to the condition of transformer when it is at open circuit. In this view, for the brush position alpha equal to 90 degree is called as open circuit or no load or high impedance or a neutral position. Let us have another case when alpha is equal to 0 degree, that is when stator or rotor axis coincide with each other. With this, the mutual induction between the two windings is maximum, and the large rotor current would produce a rotor mmf which would be opposite to the mmf of the stator. Since 2 mmf is along the same axis, so there will be no torque developed under such conditions. Further, this condition of alpha equal to 0 is similar to the transformer on short circuit. Therefore, this position alpha equal to 0 degree is short circuit or maximum current or low impedance position. So the alpha equal to 90 degree or alpha equal to 0 degree, these two positions are not the positions for the placement of the brushes for the rotor. Actually, the brushes is neither along alpha equal to 90 degree nor along alpha equal to 0 degree, but it must occupy some intermediate position as shown in figure 2c. Uh, If the stator mmf at any instant is along A to B, then the rotor induced mmf must have component opposite to the stator mmf at the same instant. That is, the rotor induced mmf must be directed along C to D. It must be opposite to the orientation of stator induced mmf. We know that for this case we have considered that the stator induced emf is along AB, whereas the for rotor induced emf it must be along C and C to D. The stator polarity at A is S1 at any instant, and the rotor induced polarity at C is S2. So there must be repulsion between like poles. So S1 and S2 will be repelling each other, whereas N1 and N2 will also be repelling each other. So there will be a torque, or there must be a rotation in clockwise direction. It is obvious that the direction of rotation can be reversed by shifting the brush's axis of the field winding. Now consider another case as shown in figure 2D. The brush axis is shown vertical. The brush axes are shown vertical for convenience as before, and the stator axis is displaced from brush axis by an angle alpha. You can see that the brush angle is the angle between brush axis and stator field is alpha. If ns is the effective number of turns of the stator, then isns is the stator mmf which is directed along the axis of this stator. For convenience in the analysis, the stator field is replaced by the two fictitious stator coils T and S. The T is vertical, whereas F is placed in horizontal position. These two fictitious stator fields are in quadrature with each other, such that the stator mmf, which is ISNS, is remain unaltered in magnitude. So when it is unaltered, then is nt, then is and nt is the number of turns of this fictitious vertical resist stator winding. Is nt is equal to ISNS cos alpha, whereas for, the NT number of turn of this fictitious vertical winding is NS cos alpha, whereas the number of turns of this horizontal winding is NF is equal to NS sine alpha. So it from previous discussion, it is clear that the for the torque production, the alpha must not be equal to 0 or 90. It must lie in between 0 to 90, and this is the case for this figure, for this considered figure 2 figure 2D. So next videos of this repulsion motor will be coming soon. You can give feedback in this regard of this construction part of the repulsion motor.